Hello, I'm Rob Freyvogel, the president of Carbinite Metal Coatings. And the reason why we're here is to discuss the benefits of texture coating within the aluminum flat rolled process. A lot of the time when we talk about coatings in the aluminum industry, we talk about smooth finishes or smooth coatings. In this discussion, we're going to focus on the other end of the spectrum and discuss how textured coatings and the increases of coefficient of friction can dramatically improve productivity and reduce maintenance cost. Here are four traditional approaches to adding texture to roll process equipment. The first is grit blasting, often used in combination with hard chroming or nitriding in an effort to try to harden up the roughened surface for added durability. The next is thermal spray, in which powdered metal is sprayed onto the surface using heat and high velocity to bond the coating to the surface. The third is knurling or rough machining. And the fourth is EDT surface texturing, which gives great control over the surface finish and is commonly used in the auto body stock finishing rolls. There are some other processes out there, but these are probably the most common. The emerging technology in the texture field is actually an older technology commonly called ElectroSpark Deposition, or ESD. Carbinite has sort of hot-rodded this technology within the past couple of decades. We've been able to make technological improvements that have led to an increased rate of deposition and much rougher surfaces when desired. As you can see here, the consumable carbide electrodes are spinning in order to break contact. The arc is relatively short and usually does not need an inert-to-gas shield. This new hot-rodded technology has made larger applications more feasible in terms of cost effectiveness. The big advantages of ESD is that it gets a true metallurgical bond with the base metal and can be offered in a variety of textures. The principal disadvantage is that it's not 100% pure, meaning there is some substrate or base material that gets mixed in with electrode material. This makes for fantastic bond strength, but negatively affects the overall coating hardness. Let's go back in time to when this all began. We first got involved in the aluminum industry by coating large pit covers in front of the cold mill. The standard operating procedure before that was textured grit paint. The problem with the paint is that the coolant would continuously get underneath the paint and loosen it. It had to be completely stripped and reapplied nearly every outage. To solve this problem, we applied a coarse grit stellite-based ESD coating to the covers. The solution was effective because the coating gets a true metallurgical bond. This was really important because there was a lot of forklift traffic here and a lot of scrap bin placements that were just dropped about. A very smooth ESD coating was applied to down ender pads. And although not shown, these get finished with a top coat of ferritic nitrocarburizing. The ferritic coating seals the surface and gives added protection against transfer. This solved the pickup issue caused by the hot ingots rotating on these pads under very high pressure. The next development in the evolution of this technology takes us to hot mill expanding mandrels. Here we have a worn mandrel that's actually ready for refacing. It takes a good amount of surface preparation to get these cleaned up and remove the galled aluminum from the surface. In this picture, the coating is applied to the worn mandrel using ESD and a robot. And finally, we have the finished product of the coating on the high section of the mandrel face. On this particular mandrel, we're actually able to apply the coating thicker in heavily worn areas to restore the mandrel to a more uniform diameter. The results were outstanding. Here's what we found. The coated mandrel works better than the original horizontal cut surface or machine knurls. By that I mean it just grips better. And number two, the mandrel does not need to go back to the roll manufacturer to have the face completely refurbished nearly as often. As far as we know, this mandrel has not been back to the mandrel manufacturer for refacing in nearly 15 years. This has been a huge cost savings for the aluminum plant. The next advancement was needed in order to reduce the coiling cycle time on a belt wrapper style cold mill. To do that, we added textured carbide coating to the face of the coiling spools using ESD. The textured coating applied to the spools allowed the mill operator to pull tension sooner and get up to operating speed much faster than before. We initially did 6 spools with 6 different patterns of coating. All the patterns seemed to work okay, so we settled on a pattern which would be the most cost-effective to apply. In 2011, we coated over 1,100 of these spools for one particular customer. According to the cold mill engineer at this plant, this modification bought them approximately 30 minutes of mill productivity per day. This has been so successful that this is now standard operating procedure amongst all the branches of the same company that are pulling the same size stock. As you all know, solving one problem often uncovers another one. In this case, the improved tension we achieved on the spools uncovered a slippage problem at the stub mandrel. This slippage would often cause an unacceptable loss in tension, resulting in a scrap coil.
Our initial fix for this problem was to simply coat the OD of the stub mandrel with a coarse grit ESD coating. This helped a great deal, but because of the very high loads, the coating still failed within a couple of months. It's important to remember that because ESD creates an alloy of the electrode material and the substrate, it matters what the substrate is. The solution to our mandrel problem was to create a set of custom inserts made from hardened A2 tool steel to which we could apply our coating.
Here is a picture of the stub mandrel with its custom inserts. These inserts have been in service over 6 months. As you can see by the scarring on the original mandrel face, these spools were definitely slipping on the mandrel. Notice that there's no scarring on the inserts. We love that A2 tool steel. The solution was a home run and resulted in a couple of other side benefits. For one, the changeover time for fresh gripping surfaces was significantly reduced, as now only the inserts needed to be changed and not the whole stub mandrel. This goes in order of about 8 hours to change the whole stub mandrel, but only 1 hour to change the inserts. And number two, the cost for shipping was dramatically decreased for recoats because only the inserts needed to be shipped and not the entire stub mandrel segments. Okay, that was a little look backwards in time. These applications are still being used, but we're not standing still. We continue to hunt for new applications in the aluminum mills. In the ESD world, typically, if you want a smoother ESD finish, it's a very, very slow process. Within the last 3 years, Carbinite has made great strides in both reduction of coating time and achieving smoother, more consistent finishes. We can now apply our smooth carbide coating at nearly 4 times the speed that we used to and achieve finishes all the way down to 2RA. We think this new technology may be used as a table roll coating with great potential to eliminate pickup and stickers. It also may reduce hot mill cycle times as the direction of ingot may be reversed faster. So let's summarize what improvements that ESD has brought to us within the last decade. Increased mill output by reducing wasted time that was caused by inadequate tension at the early phases of the rolling process. The elimination of scrap coils due to slippage between mandrels and spools. And reduced maintenance costs related to aluminum transfer or pickup. So there you have it, a very quick look into what's going on in the texture coating world, at least as it relates to the aluminum flat rolled process. If you would like to review the aluminum show video of this presentation and panel discussion that followed, go to carbonite.com and scroll down to the primary metal section. The video link will be there. If you would like to have a conversation with Carbonite and learn how our metal coatings might add value to your business, please email us at sales@carbonite.com or call 724-586-5659. On behalf of the whole Carbonite team, we thank you for watching.